Let's take a look at Newton's third and final law of motion. Think about a game of tug-of-war. Each team exerts a pulling force, but with equal and opposite forces, the rope doesn't move. There's no acceleration. It's a tied game. Now, consider two cars colliding in a crash test for a car company. Each car exerts force on the other, and each car is crushed as it decelerates to a full stop. The formal definition of Newton's third law is that every action has an equal and opposite reaction. Another way to state it is, forces come in pairs. What other action and reaction pairs can you think of? How about a competitive swimmer in a pool? She uses Newton's third law in several ways. She pushes the water back with her hands, which, in turn, creates a force that pushes her body forward in the lane. Do you see the force pair? Then, she turns to execute a flip, pushing the wall, as the wall pushes back with an equal force in the opposite direction. Another force pair. And, due to Newton's second law, the very massive wall accelerates very little, but the less massive swimmer accelerates a lot. Now here's a familiar scenario. Newton's third law says that when trapped air escapes a balloon, an equal force moves the balloon in the opposite direction. How does Newton's third law apply to this puppy lounging in the grass? The force of the puppy's weight is directed down, while an equal force on the ground is directed up. Without the balanced force pushing up on him, the puppy would either sink into the ground or lift off. So now that you know Newton's third law and the existence of force pairs, think about how the law and those force pairs apply to your aerospace investigations.